Your subscribe keeps us motivated. Subscribe now.
A ball is thrown vertically downward from a height of 20 meters. So let's write the initial conditions. H is 20 meters with an initial velocity V0. Okay, fine. It collides with ground, loses 50% of its energy in collision. Okay, fine. And rebounds to the same height. Okay, fine. So it is losing 50% of the high energy and rebounding to the same height. That's a quite important condition. The initial velocity is V0 is. We have to find the initial velocity, right? So when it hits the ground, let's see what will be the energy. So let me write here, when it hits the ground, its total energy will be the sum of kinetic plus potential energy. So kinetic energy will be half mv0 square plus mgh, where mgh is the potential energy, right? Now it is saying that it is losing its 50% of this total energy. So losing its 50% of this energy, and it is going to the same height, which means that energy, the remaining 50% energy, is responsible for the particle to give that particular height. So 50% of this energy, half mv square, must be responsible for the ball to reach up to that height. So potential energy attained by the ball, mgh. Now 50 by 100 is 1 by 2. Let's take that 2 on the other side. So half mv square plus mgh, and 50 by 100, let me repeat again, 50 by 100 is how much? 1 by 2. I am taking that 2 on the right hand side, it will become 2 mgh. Let's take this mgh on the right hand side. So half mv0 square will be equals to 2 mgh minus mgh, mgh. Let's cancel out this m with m, correct? So we left with v0 square, that will be equals to 2gh. And how much is 2? G is how much? 10 they have said to take, and height is how much? 20 meter. So that is v0 square, and this implies v0 square is equals to 400, or v0 is equals to 20 meter per second. That's our answer, option C.